So if you go to the course documents of our course, you'll see that I did not really upload anything, but I created a few folders. And today we are here in week 13's folder. And so I will explain. So this week 13, clearly so we meet twice, right? So we'll meet today, we meet on Wednesday as well. So what I plan is that I'll cover chapter 7 today, then I'll do some exercises on Wednesday from the textbook. Then next week I will do some exercises, but in Excel and R. Those will be primarily empirical the empirical problems. Then I'll explain chapter 8, week 15, and then I'll do some exercises, and then on week 16, we will have a review for the final. And on December 16th, which is in week 17, we will have our final. So let me ask you guys, how are you doing? So are you doing the homeworks? I have not really checked anything. I have not really seen if you guys are doing homeworks, but if you are, that's perfect.
Struggling with empiricals for
Okay,
chapter 4. Yeah, chapter 4. I mean chapter 5.
If you can email me specific problems,
Okay.
I will consider doing those problems during maybe not next, but definitely next week.
Okay. Thank you.
No problem. So just email me the problems you're showing, and I will try to do it because I'm anyways planning to do some empirical problems next week. So.
I have a quick question, Professor. About our studio, how much would you recommend for us to focus on like actually learning how to do problems in R? Because like different problems would have to import different data, so it's just like this whole different world of it, and it's very easy to do it once we are following step by step what you are doing, but I've tried doing it on my own and I've come across like issues. So like how would you suggest that we try working that way or just stick to the original ways that we were doing?
I understand. So first of all, the answer to this will be what is your plan? So what do you want to be right after you graduate? So if you want to work in private sector, for a consulting firm, for the companies who need data analysis, then I mean, they're not doing it in Excel. They're doing some of it in Excel, but they're primarily doing it in R, in Python, in MATLAB, but very often in R and such. So I would say it's really very important. That's why I am trying to give you guys some basic knowledge of skills of doing stuff in R, because I know that it's very useful for your future. But for the exam, you will not need to do things in R, because in the previous courses I taught, right, students did well in the exam and they were not necessarily using R. So did I answer your question?
Yes, definitely. Because question was mostly about the exam. Because when we do on our own, I have time to pause, look back. So I just wasn't sure if you recommend us doing exam problems in R. I was just worried that it might take away time if we come across something that's unfamiliar or something. But it absolutely makes sense. And yes, it is useful, and we're trying to learn. I just wasn't sure about the exam. So thank you for clarifying.
Perfect. So maybe I can also add. If you noticed, I'm referring to everybody. If you notice, if you are skilled in R, then doing problems in R is like reduces time of solving problems very, very significant. So depends really on you. So do you feel like that you are very skilled in R? If you are doing problems in R faster than in Excel, or then maybe you by using your calculator, then definitely use R. It really is about you guys. Okay, so let me now share our blue screen, blue document, which is this, and let me start today's class. Please stop me at any time because we have enough time to cover everything we are supposed to cover in this course. Okay, so today's topic, which is the topic of chapter 7, is hypothesis tests for multivariate models. Hypothesis tests at confidence intervals for multivariate models.
So you have to switch screens.
Oh, I
We're
didn't.
still on black.
Okay. Chapter 7. This is about hypothesis tests and confidence intervals. For guys, if you are not using microphone, please turn it off unless you're asking questions. For multivariate models. Let me start by specifying, or maybe re-specifying, because we already specified the multivariate model before. Let's do it again. So the model is this, right? yi equals beta 0 plus beta 1 times x1I plus beta 2 times x2I plus and so on, plus beta k times xki and plus ui, right? So this is the population relationship, right? Right. But do we know these? I mean, do we know the values of beta 0, beta 1, beta 2, and so on, beta k?
No.
Unknown parameters. Right. Okay, then if you don't know these two population parameters, how can we know? Guys, I hear a lot of noise that I don't know why is that. Okay, now it's, I think, better. First of all, let's recall ourselves the true population line. So the true line is what? Yi equals, sorry, and that's incorrect because I should have written expectation of yi given all of your x's, and I will stack all of those x's in this bold x equals beta 0 plus beta 1 times x1 plus I plus. So we obtain this from the true population relationship. But what is the key assumption that we make here? Can you guys tell me? So to go from this population relationship to the true population line, we have to make an assumption. What is it? The assumption that we need to make is the following. The expectation of EY given all of your x's, and this is the bold x that contains all of the x's, is 0. This is actually the key assumption. Okay, since we don't know these true betas, what can we do? We can estimate this model by ordinary least squares method and obtain what? The estimates of beta 0, beta 1, beta 2, and so on, beta k. The estimates are denoted by hats. And then the next question naturally is what? Are these estimates good? So then we need to recall what do we mean by an estimator to be a good estimator. So we know that an estimator to be considered as a good estimator needs to satisfy certain requirements: unbiasedness, consistency, and efficiency. And the estimators obtained from the OLS under certain assumptions, one of the assumptions is whatever I already gave you guys, this one, then these estimators are good. So whenever you have, okay, what is the difference between an estimator and estimate? Can you tell me?
An estimator is like I would say like a function that allows us to get an estimate, which is an actual value of a function.
Thank you very much, because I would have a difficulty to say it better. So you are absolutely right. So let me say in general say beta j hat equals something, right? It is a function. It is some function, right? You have, let's say, then you have only one independent variable and clearly one dependent, then you know that. And okay, so then you know that this is covariance between y and x divided by variance of x. Here j equals 1, right? And beta hat j equals y bar minus beta. It will be like, okay, let me disregard this. Let me write beta 1 and beta 0, right? Beta hat 1, beta hat 0. It will be beta hat 1 minus, sorry, not minus, times x bar. So why was not I able to give you guys this expression? Because I mean, when you have, as I said before, not today, but last class, maybe a class before, when you have more than two independent variables, even like when you have more than one independent variable, the analytical expressions, so this here is an analytical expression for beta 1 hat, right? So when you have more than one independent variables, the analytical expressions are either very complicated or cannot be obtained at all. Guys, are you here with me?
Yes.
So as...
Yes, we are here, Professor.
Thank you very much. So as one of you guys clearly noted, beta 1 hat is a function, right? Of what? Can you tell me? Y and x, right? Is there anything else in this expression? So beta hat 1 is a function. And that's why beta hat 1 is an estimator. Very good answer. And but once you plug the numbers for y and x, then you get the value for beta hat 1. Maybe it equals to 1.6, whatever. Once you have the value, then beta hat 1 becomes an estimate. Am I clear?
Yep.
So that's a difference between an estimator and an estimate. Again, let's repeat. An estimator is a function of what? Of the variables, of the values of the variable. And the estimate is the value obtained once you plug in the numbers for the x's and y. So what do you believe in this, in estimates, unless you know that the estimator is good enough? That's a question.
No.
Right? So first, that's why. First, you need to make sure that the estimators are good enough. So then you know the requirements, right? That estimator should be unbiased, should be consistent, should be efficient, and then we believe in the estimates, right? Once we have the values for the estimates, what can we do, guys? What can we do?
We can test them.
We can test hypothesis about
The estimates about the population.
not estimates, not estimates. That was a mistake, but it's fine. But you also corrected it. About the corresponding, sorry, corresponding true population parameters. Let's say I have this model okay, and let's say we want to test the hypothesis about beta. Let's say here, let's say k equals 12, let's say. So you have variables and 12, right? So go from 1 to 12. And so let's say we want to test the hypothesis about beta 7, right? What do you need for this? Can you tell me what do we need to test the hypothesis about beta 7?
You need an estimate of beta 7.
We need what?
An estimate, a value for beta 7.
Good. What else?
We need the standard error
Of
beta 7.
no.
Of
Beta
estimated.
hat 7.
Beta 7 hat? No?
Beta hat 7.
That's correct, partially. But I will go back to this later. But tell me, what is this?
Wait, sorry, is it sigma hat beta hat 7?
Good. So now you are guys absolutely right.
The first one is sigma of actual beta, which we don't have.
No, we know that. That's 0. Can you tell me why?
Oh, because, wait, sigma is standard deviation, right?
Yes.
Well, for estimate, we need standard deviation to see how much does it vary from actual data. So if in true population, it's not going to vary at all.
Correct. Correct. So, correct. So we know that even though we don't know the values of these, right? The true ones, true values. Sorry, the values of the true betas. Even though we don't know that, it does not mean that they vary. They don't have any variation. Do you see what I mean? There are the values of for these betas, true betas. So we simply do not know the values of those betas. But they are there, simply we don't know. They are there, they don't have any variation. That's why sigma of any of the betas is 0. This is not interesting for us. But guys, it is very good that you got this right. Okay, then let's specify the hypothesis. Let's specify the hypothesis about beta 7. Let's say it equals to beta 7 at 0, which stands for the, what is this? Can you tell me? What do we call this?
The null hypothesis.
No, the null hypothesis is everything. Okay? That's what we call it. Or in other words, you can say this is the same as the value of beta 7 at the null hypothesis. Guys, I'm asking to everyone, are you guys with me?
Yep.
Good. So now I'm happier because I have more students than during the last class. Okay. So and you guys know that the alternatives can be specified in 3 different ways, right?
Yes.
This is one of them. And others are what?
Beta 7 is greater than the null
Greater than,
hypothesis size value.
then there's strictly less than.
Very good. You need to know this as well. Okay, let me challenge you a little bit. Will the critical values for the one-tailed, this is for one-tailed, this is one-tailed test, right? And for the two-tailed test, be the same.
Would it be no?
Yes. We will do exercises on this, guys. You don't have to worry about this. We will have a lot of time for exercise, but try to follow. Okay, so when we specify the hypothesis, what is the next step?
You got a t-stat?
Good. And this is what? Can you tell me?
Beta had 7 minus the hypothesized value. Beta 7.
This is 7 minus beta 7 at the null, right? This is the hypothesized value, as you correctly noted. And then we divide this on the signal head of beta head 7. Can you guys tell me what is the value that we usually take for this?
0.
Why?
Because to know if beta has 7 has any impact on the function or the line. If it's 0, then that means that it does not have any impact on the line.
Hello? We can't hear you.
Sorry, what about now?
Yeah, we can hear you.
So,
Now we can, yeah.
good. So what I asked is, what do we say when we reject H now that I specified about? What do we say? Guys, are you with me?
H null failed the test.
No?
Is it that H null at a certain significant level we reject H null?
So if you reject H null, that means what is it? What is your conclusion if you reject H null?
We fail to reject H alternative.
That's true, but no, I'm saying, what is the H null? Recall what is H null? H null is that beta 7 is equal to 0,
0.
right? Okay, then alternative clearly is, okay, it can be that it's not 0, but what does it mean if you reject this?
We accept H alternative.
No. Okay, that's true. I'm not asking about that. That if you reject H null, that means what? That beta 7 is
Has
not 0, right? So that
Yes.
means that X7 does affect what? Why? That's your conclusion, guys.
Would you say there's correlation?
Yes, there is, but you are not interested only in the correlation. This OLS is not about correlation. It gives us more. It gives us causal relationships between X and Y. If the assumptions are satisfied, I mean the OLS assumptions, and right? Okay, do you see what I mean, guys? So if you reject H now, then X7 does affect Y. And so X7 is relevant. And should be part of the model. We also say that beta 7 is significant. Guys, please follow. When we reject H now, we also say that beta 7 is significant. That's just a notion. Why? Because what does it mean? It means X7 plays a role it affects the variation in y. So we also say that beta 7 is significant. Okay, this is an important thing to know. It's not about beta 7 only, it applies to any beta. And we need to know what do we mean when we say that beta 7 is significant, beta 5 is significant, beta 3 is not significant, beta 9 is insignificant. So you need to know all of these terms. So how are you guys? Are you following?
Yeah, we're following.
Great. Now let's, okay, as I said, guys, I will do exercises next Wednesday. But now let me ask you something. How many ways do we have for testing the hypothesis? Do you remember?
3.
Very good. Can you tell me what are those ways?
You could do the p-value test, the test statistic, and the confidence interval test.
Perfect, perfect. So that's amazing. Okay, there are 3 ways. Based on test statistic. Second is p-value. Third is confidence interval. So can you tell me when would you reject H null about, do you remember the H null? When would you reject H null?
If the hypothesized value falls outside of the confidence interval.
It means that you would fail to reject H null. No? You said inside or outside?
Now, if it's outside, then we reject the null
hypothesis. Perfect. So I heard it. I heard that you. Okay, so that's me, but you are right. So absolutely. So if let us say 0 false where?
And the confidence interval.
No. Sorry, guys. Outside. Reject H now. Can you tell me? Can you give me the expression for the 99% confidence interval for beta 7 0? Not 0, beta 7?
Beta 7 plus or minus, I think it's 2.58, I think.
2.58.
Times the standard error.
You should have said head. Yeah. But Otherwise, it's good. But we can only take this if the sample size greater or equals than 120. Good, guys. I think you are doing pretty well. Hopefully, everybody is doing well. Okay, now, p-value. What is the p-value?
Is the area that falls outside of the interval. So on
Area
either,
of the tails.
But can you tell me, can you be more specific? Okay, tails, that's good. But what do we have here and here?
It's the area of the rejection region.
Not quite. But can you tell me, do you see the blue screen?
Yes.
If I say that the p-value for two-sided test, if I am telling you guys the area 1 plus area 2, right? So if I'm telling you that's the p-value, then what is it that you have here and here?
Well, since they are the same, it's practically just going to be 2 times area 1. And that is when we calculate 2 times p of z smaller than negative absolute value of test statistics, which like we just do in Excel for no.
Great. So you already said it. So perfect. Everything that you said is correct. So simply, I wanted to say, what do we have here and here? And you said it. So here you have test statistic. And here you have minus of test statistic. Okay, guys, do you see what I mean? It's not the critical value, it's the test statistic. So these areas 1 plus 2 is the p-value. Or as you said, 2 times 1. Area 1 is p-value. Or formally, you can write it like this. P-value equals 2 times probability that capital C is less than minus the absolute value of your test statistic. Which you said. That's good. And those of you guys understand this is perfect. If there's anything you don't understand, please let me know so that I can explain. Perfect. So that's one part of this chapter. As I said, we will do examples next Wednesday. But now let me introduce a different type of hypothesis test. So before, we were only discussing the hypothesis test about a single population parameter. But we also sometimes need to test the hypothesis about a few of the population parameters simultaneously, right? Why is that? Let me say, we call this model say this is our model. It is possible that we may find that none of these betas are significant. So if you do four hypothesis tests, 4 individual hypothesis tests about the significance of beta 1, beta 2, beta 3, beta 4, you may find that none of them are significant. Okay? But it can also be, it is also possible that maybe, let's say, even though beta 1, beta 2, beta 3, beta 4 individually may not be significant, meaning that these variables exist individually do not matter or do not cause or explain any variation in your dependent variable. It is possible that at least a few of these parameters can be jointly significant, which means that at least a few of these variables can be playing a role in explaining the variation in our dependent variable y. Guys, am I clear? And that's why we need to test sometimes a joint hypothesis about a combination of or different combinations of betas. Okay, so up until now, are you guys following?
Yes.
Yes.
Thank you. Okay. Okay. I will explain this on an example.
Sorry, I do have a question. How is it possible that if parameters, if betas individually are not significant, that in combination with others they are? And like, which combinations do we choose? Like, then will beta 1, 2, and 3 together be significant, but 3, 4, 5 not? Like, how is it possible?
Let me give you answer like this. First of all, data shows sometimes that, and if you also take a look at our real life, sometimes individually we have less power, but when we work together, we find that we are more powerful. Sometimes we may not be able to complete a task individually, but together we find it easier to complete the same task. So I think it's relatable to this. Do you see what I mean? I think that is relatable to this. Okay. But I'm thinking to give you a better answer, but that's clearly an answer. But let me think. Okay, I'll think about a better example, but whatever I said is I think it can be considered as an answer here. So let's respecify our model. Let's say we want to test the hypothesis that beta 4 is 0 and beta 5 is 0. The alternative is that beta 4 is not 0 or beta 5, you can say, or beta 5 is not 0. We call this a test of, the joint significance of beta 4 and beta 5. How do we do it? What is the next step? Can you guys tell me? The logic is the same. Simply the logic is the same. So the next step will be what?
Statistic.
Good. Yes, the next step is, like always, calculate the statistic. Which is known as F statistic. Okay. Why do you think the test statistic that we calculate here is called the F statistic? I will tell you. Because okay, that's right. Okay, the test statistic that we calculate for this joint test follows the F distributions. Therefore, we call the test statistic the F statistic. Now, how do we calculate it? F statistic can be calculated in two ways. One, based on R squared, not on the adjusted. based on the sum of squared residuals. So below, I will give you guys the expressions for this. Okay? Again, don't get overwhelmed. These expressions are sometimes quite long, but I'm not asking you guys to memorize anything, right? So, the expressions. Okay, this is clearly based on SSR. The same result can be obtained from by calculating F statistic using R squared. Based on R squared. Now I want to, first of all, we need to differentiate between the restricted and unrestricted models. If we go back to our model, guys, if you have any questions, please stop me at any time. Let me copy this. Okay. Guys, you still see the blue screen?
Yeah.
Yes, but nothing is written on it.
Yes, I know. But I wanted to copy this. Now let me write something. So we have two models. We have one model, but this one model is generates two models. One is itself, the other one is the restricted model. So the restricted model is the model at H null. So the restrictions are imposed. Betas are imposed. So can you tell me what will be the restriction, the restricted model in our case? Beta 0 plus what? Guys. So can you please impose these restrictions on this model?
So it will be beta 1 times x1 of I plus beta 2 times x2 of I plus beta 3 of x3 of I plus beta 5.
No, because you have to impose these restrictions, right?
Oh, that's beta
Beta
5 as well. Okay, cool.
beta
So
for
we don't include plus, so that will be just plus your 5.
yes. So this will be the restricted model. Am I clear for everybody? What we did is that we imposed the restrictions at the null hypothesis on this model. This model itself is the unrestricted model. Okay, do you see what I mean? The original model will be the unrestricted model. Am I clear, guys?
Yep.
And so again, as I said, I will give you guys examples. I will do the examples in class and exercise also next Wednesday, not next Wednesday, this coming Wednesday. But still, I think it's useful to understand first what we are doing. So we can obtain both SSR and R squared. So from this model, right? Do you agree with it? And the same thing here. So guys, I use R squared and R squared interchangeably. Same thing.
Quick question. Do we carry the disturbance to both of the models through or no?
Sorry, can you please repeat? I could not hear.
Do we carry the disturbance throughout the models, both the restricted and the unrestricted? Because it's not written down on the blue screen.
No, we assume that disturbance is first of all the assumption that we have. First of all, that's a very good question, but the assumption that U should not be correlated on your axis should be satisfied for both models. You will have less number of axes for the restricted model clearly, but the disturbance term should not be. How do we know this? We don't know this. But there are ways to test if this assumption is applicable. Did I answer your question?
Yes, thank you.
Okay, so then in these expressions, guys, here we can obtain all these values, right? These, that, these. Do you agree with me?
Yes.
This Q and that Q are the same, and those are number of restrictions. In our example, the number of restrictions was what?
2.
Right. Okay, good. Because we had only 2 restrictions, beta 4 was it, right? 4 was 0 and beta 5 was 0. That was the only 2 restrictions we had. So n is the sample size in both places. This k here and here, that is the number of, please remember, that's number of independent variables. Or slopes, slope coefficients. Because number of independent variables coincides with the number of slope coefficients, right? In the unrestricted model. So guys, Q is known as the, usually referred as I am finishing like in a minute. The numerator, degrees of freedom, and n minus k minus 1 is usually referred as the denominator, degrees of freedom. So today I'll finish class here. I have to say that I made an announcement on this on the CUNY Blackboard, but today I did not have an office hour. I will have office hour this coming Wednesday. I think I will double check, but I think the Zoom link for that office hour and time and everything is on the CUNY Blackboard. I will double check though. So this is it for today's class. I will give you guys more information, insights, examples, exercises this coming Wednesday. So thank you guys very much, and I hope to see you all next Wednesday.
Thank you, Professor.
Thank you, Professor. See you next Wednesday.
Thank you.
Thank you, guys.
Thank you, Professor.
No problem.